Welcome to today's Explainer. You know, every single great scientific discovery out there, it all starts with someone daring to ask a massive why or how about the world around us. But how exactly do we take those big, curiosity-driven questions and turn them into real, scientifically backed answers? Well, today we're unpacking a really interesting curriculum designed for 8th grade scientists. It maps out this highly structured, deeply rewarding process of scientific inquiry. We're going to break down the exact steps needed to go from a simple question to a full-blown, robust project. And, as you'll see, we'll also look at how this source material actually ties scientific research into a much broader moral and philosophical framework.
Here's a quick look at our roadmap for today. We'll start with the foundation of inquiry, then look at why good research matters, and cover finding and citing sources. After that, we'll move into building models and experiments, check out some real-world science examples, and wrap it all up with morality, education, and wisdom. Let's dive in.
So part 1, the foundation of inquiry, building on real research.
Okay, so having a big idea is a fantastic starting point, right? But finding the actual answers takes some serious structured investigation. You literally have to dig for the facts. The HeroesmartAcademy curriculum actually grounds this whole process in Proverbs 10:14, which says, "Wise men store up knowledge." So in this framework, actively seeking out the truth isn't just some boring homework assignment you have to check off a list. No, it's defined as the active practice of wisdom itself. Within the context of this curriculum, when learners are researching, they are meant to be literally practicing how to be wise.
Moving right along to Section 2, Why Good Research Matters, preparing for your project.
Before anyone starts mixing chemicals or building elaborate structures, we've got to ask the practical why. Like, why do we need to hit the books before we hit the lab? Well, for one, research prevents costly mistakes. Just ask the NASA scientists who lost the $125 million Mars Climate Orbiter back in 1999, all because of a simple math conversion error. Talk about a tough day at work. But beyond just avoiding disasters, research gives you that absolutely crucial background information. It helps you ask much more specific, fascinating questions, it builds a really deep understanding of your topic, and ultimately, it prepares you to actually explain your ideas clearly to others. Because let's be real, you simply can't teach what you don't truly understand yourself.
Which brings us to Section 3, Finding and Citing Sources, Gathering Trustworthy Evidence.
So how do we actually gather this evidence responsibly? Step 1 is starting broad. You know, look at books, websites, articles, or maybe even conduct some expert interviews. But step 2 is the real game changer here. Verify. You can't just believe everything you read on the internet, right? A random blog post from 2012 probably isn't going to help you build modern solar technology. Ensuring your sources are accurate, trustworthy, and up-to-date is an absolute must. And finally, step 3 is citing those sources. Giving proper credit is just non-negotiable in science. It proves you put in the hard work, and it lets other people easily verify your claims.
Next up is Section 4, Building Models and Experiments, Designing Your Test.
All right, once your background research is totally locked in, you're at a crossroads. You have to choose a path. Are you doing an experiment, or are you building a model? If you go the experiment route, you need a highly structured plan. We're talking about defining specific variables, knowing exactly what you're going to measure, and deciding how to record that data so it actually makes sense to you later. A model, on the flip side, is all about visual and functional accuracy. Even if you're building it with simple, everyday materials around the house, a physical model has to accurately reflect how those systems behave in the real world. Both paths take immense critical thinking. They're just applied in slightly different ways. But hey, keep in mind that scientists do not work in a vacuum. They always review their plans before launching into the lab. Seeking guidance, asking a teacher to review your variables, or double-checking your model's accuracy. That is exactly what real-world professionals do every single day. Collaboration is a huge, vital part of the whole scientific process.
Let's look at Section 5, Real-World Science Examples, Learning from Peers. Sometimes the absolute best way to understand a structured process like this is to just see it in action. Let's look at a few examples from the source material. Take Sophia, for instance. She designed a model house with solar roofing. To do this, she secured trustworthy research directly from NASA's website and meticulously cited it. Awesome, right? Then there's Malik, who chose the experimental route. He tracked how colors absorb heat. He did this by wrapping jars in different colored paper, leaving them in the sunlight, and carefully measuring the temperature every single hour to perfectly track his variables. And then we have Ella. She built a physical model using simple stuff like balloons and straws to accurately demonstrate how our lungs expand and contract. So that's 3 completely different paths, but all of them are deeply rooted in the scientific method. Finally, we arrive at Section 6, Morality, Education, and Wisdom, the heroesmartacademy philosophy.
At this stage in the curriculum, it really challenges its students to apply everything they've learned. It asks them to outline their specific project type, list out their materials, and identify 3 reliable sources they plan to use. But it doesn't stop there. The lesson poses a much deeper, more reflective question to the kids. How exactly does that proverb we mentioned earlier, wise men store up knowledge, how does that actually connect to the practical, physical act of doing good research?
Well, that reflection leads directly into the foundational philosophy of this Godly Learners series. The goal here is to combine education with biblical morality. The curriculum directly asks learners to step back and consider what is the overall point of being highly educated or being capable of building these complex scientific models if you lack the moral compass to make good choices. The whole idea is that scientific knowledge is an incredibly powerful tool, for sure, but it's one that requires strong moral guidance. That way, the choices made with all that knowledge don't end up hurting others.
The series wraps up its lesson by referencing Romans 8:6-7, which associates spiritual mindfulness with ultimate peace of mind. The framework is suggesting that blending rigorous scientific inquiry with a spiritually grounded character is the intended formula for true success within this program. So, as we look at how curriculums like this aim to shape the next generation of scientists, it leaves us with a pretty fascinating, broader question to ponder today. In an era of incredibly rapid scientific advancement, is knowledge alone enough to build a better future? Or will the morality behind the science ultimately determine our trajectory? It's a lot to think about. Thanks so much for exploring this explainer with me, and I'll catch you next time.